Hello everyone, my name is Bhushan Patil. Today I am giving a presentation on a big table, which is a distributed storage system for the structured data. It is a distributed storage system which is used at the Google. So it's a latest one application. Then today's presentation includes these points: the introduction, data model, API, building blocks, implementation of the big table, then refinements to make the improvements in that, then conclusion and the references. Okay, so let's go through these points. The first one is introduction. So we know the structured data. So in the today's world, in term of internet, it's a very large, the scale of the structured data is very large. So to make them implementation, Google introduced these big table concepts which implements the functionality at low cost and give a high performance, and it doesn't support the relational data model, so that it has their own API to make functions like inserting and deleting some rows and columns. So next point is a data model. So here in the diagram there is a data model for the big table. The big table is a sparse, distributed, persistent, multidimensional sorted map which is indexed by the row key, column key and a timestamp. The syntax is given is here, which is a string. The syntax is mentioned in a round brace, like row is a string, then column is also a string, and the timestamp. So next is a row. So row key are arbitrary string which currently up to 64 KB, and the typical size is usually 10 to 100 bytes. The row operations are atomic, means we know the atomic property. So the row operations, whatever the row operation we perform, those are atomic, and the data is in a lexicographic order. Then big table sort its data on the basis of keys. Let's say an example, reversing the domain names. Suppose we have an web address www.llama.edu, then by using the reverse domain way, we can insert it as a edu.llama.www in this way. So the table is split among the rows into multiple rows, then that multiple row range is called as tablets. So the column families. So here is a diagram which gives some brief idea about it. What is the row key, then what is the column family. The data is sorted is usually of the same type, means let's see the column family, the anchor family merged together, then it contains the column key as a qualifier also. So the by looking this diagram we get some more information. So the timestamp, each cell has multiple version of the same data. These versions are indexed by the timestamp, so they can be assigned by either big table or the client application, and the versions are sorted in a decreasing order, means with the help of the versions are controlled with the help of timestamp also. Then the next one is the API. As I told before, this structure doesn't support the relational database model, so it has their own API to perform the functions like creating and deleting the tablets and column families, writing the data, and deleting the data in the cells also. If you want to perform some lookup operation on specific rows, we can import these APIs to perform the function and write a script to execute that functions. Then the building block, which is the one of the important part of this presentation. So GFS is used to store the log and data files. We know the GFS, right? The Google file system. Then Google SS table, it is also one of the Google's data structure which is used in this big table also, which provides persistence, then immutable ordered maps, keys and values. Each SS table contains the sequence of block which perform and lookup operation with single disk. Then another is a Chubby. It is a log service which consists of 5 active replicas. One is master and the other act as a slave. So it uses the Paxos algorithm to keep each replica consistent. So the Chubby client library provides some consistent cache so that the data can be accessible easily, and the Bigtable uses Chubby to ensure one master at any time. Means every server is updated every time. So to discover some table server, and their user availability is also improved. Then this is the implementation diagram, how it works. The implement consists of 3 major parts: the Bigtable client library, then master server, and the tablet server. So each block represent their roles and suggest means how they work. They are giving the arrows. Means Bigtable client library performs metadata operation, read write operation, perform some load balancing operation also. So this diagram gives some brief idea. Let's move to another one. So how does client find the tablet? So as we just look through the Chubby, which store the root tablet location and which further store the metadata tablet, and each metadata tablet gives their descendant tablet address. So this hierarchy is important so that Chubby file initiate the root tablet. So this is how each client find their required tablet. So tablet assignment, each tablet is assigned to one tablet server at a time, and the master server keep track of this operation, which performs some important operation like set the live tablet server with current assigned tablet to server, then set unassigned tablets, manage the load balancing for each tablet server. When a tablet is unassigned, master assign that tablet to the tablet server by sending a load request to that particular tablet server. So tablet serving. So this is the diagram which gives some brief idea. So updates are committed to memtable cache. Memtable is one type of cache which holds the recent values, and SS table store the older values. The compaction, as we write more execute, as we write some operation and execute, the size of memtable increases. So minor compaction, when memtable reaches its threshold, the memtable is frozen and the memtable is created, and the frozen memtable is converted to SS table. And the major compaction, it rewrite the multiple SS table into the one SS table and keep only live data. These are the some refinements point which takes this topic furthermore, but I'm just listing the which are the important refinements here, just like Bentley and McCloy scheme, which is perform some algorithm compression. Then Bloom filters on locality groups also is there to perform some data specific row and column pair, which reduce the number of disk seek. So and the cache for the read performance, scan cache and the block cache. So that's it. Then the conclusion, in conclusion, the data model applicable to the broad range of clients. The system provides the high performance storage system on a large scale, like a petabyte of data access, thousands of server, millions of queries per second, billions of URL with many version per pages. So this is the Bigtable implementation and how they are implemented at the Google. So that's it, and these are the references which I have gone through to make this presentation. Thank you.